integrated temperature sensor is a product of semiconductor technology development. Since its introduction to the market in the 1980s, it has gained increasing popularity due to its good linearity, moderate accuracy, and high sensitivity. First, let's recall the temperature characteristics of semiconductor p-n junctions. In this lesson, we will learn about the characteristics, principles, and output forms of integrated temperature sensors. While researching the temperature characteristics of diodes, it was discovered that the temperature characteristics of the transistor emitter were similar to those of the diode but with better linearity and interchangeability. Transistor temperature sensors were put into use as early as 1970. Integrated temperature sensors, introduced in 1980, are semiconductor integrated devices. They incorporate a thermally sensitive transistor, amplifier, bias supply, and linear circuit on the same chip, enabling temperature measurement and analog signal output as dedicated IC devices. First, we will learn the meaning of integrated temperature sensors. Essentially, integrated temperature sensors are a type of semiconductor integrated circuit. Integrated temperature sensors have advantages such as good linearity, moderate accuracy, high sensitivity, small size, and convenient use, making them widely applicable. Next, we will study the output forms of integrated temperature sensors. The output forms of integrated temperature sensors include voltage output and current output. The sensitivity of voltage output types is generally 10 mV per Kelvin, with an output of 0 volts at 0 degrees Celsius and 2.982 volts at 25 degrees Celsius. The sensitivity of current output types is typically 1 microvolt per Kelvin. Integrated temperature sensors include AD590, AD592, TMP17, LM15, etc. Analog programmable integrated temperature control switch modules include LM56, AD22105, etc. Next, we will learn the characteristics of integrated temperature sensors. Firstly, integrated temperature sensors are made using the temperature characteristics of semiconductor p-n junctions. Compared to other temperature sensors such as thermally sensitive resistors and thermocouples, they have characteristics like high sensitivity, good linearity, and fast response. Additionally, for temperature sensors integrated on a single integrated circuit with driving circuits, signal processing circuits, and necessary logic circuits, they also have features like small size and convenient use. Secondly, the temperature detection of integrated temperature sensors is based on the relationship between the forward voltage of the p-n junction and temperature. When the collector bias current IC of the transistor is set to a constant, the voltage between its base and emitter is approximately linear with temperature. Transistors with different processes and structures have different forward voltages, while their temperature coefficients are similar, about 2.2 mV per degree Celsius. Lastly, we will learn about the working principles of integrated temperature sensors. Let's observe the internal circuit diagram of the integrated temperature sensor. The two crystal triodes VT1 and VT2 in the diagram are temperature detecting transistors pairs. Their bias current ratio is 16:1. After the feedback of the precision operational amplifier reaches balance, the difference in forward voltages between the bases and emitters of the two transistors, UB, is added to both ends of R2 and then flows through R3 to ground. The emitter voltage UT2 of VT2 in the diagram has a positive temperature coefficient of -2.2 mV per degree Celsius, while the emitter voltage of VT1 has a negative temperature coefficient of -2.2 mV per degree Celsius. This results in a zero temperature coefficient reference voltage at the output of IC1-1 operational amplifier, while IC1-2 provides an accurate 10 mV per degree Celsius output at its output. Silicon PN junction integrated temperature sensors operate within a temperature range below 700 degrees Celsius. Integrated temperature sensors are generally used to measure the temperature of their package. If packaged within other integrated circuits, they can be used to measure the temperature of the integrated circuit itself, achieving temperature protection. Because integrated temperature sensors are active sensors, they can conveniently measure the temperature of distant targets. Furthermore, temperature sensors can also be categorized into 3 types: analog output, logic output, and digital output. Analog output types are commonly used in temperature measurement and temperature compensation systems. Logic output integrated temperature sensors are simple to use and cost-effective, typically applied in temperature control systems. Digital output integrated temperature sensors generally have a serial interface for direct communication with microcontrollers or other digital systems. In this lesson, we primarily focus on the characteristics, principles, and output forms of integrated temperature sensors. After class, please search for applications of integrated temperature sensors in household appliances such as refrigerators, air conditioners, and washing machines, and understand their working principles. That concludes our lesson for today. See you in the next class.